Okay, so we're gonna make a MUX switch, or a MUX. It's in the same family as a DAC, digital to analog converter, and ADC, analog to digital converter. What it does is it uses a binary sequence of zeros and ones to change what pins are active and which pins are inactive. You can literally take 8 of the receiver feeds instead of having to go to channel the pin 2 or pin 3 on the Arduino, which are the standard interrupt pins on the Arduino. You're stuck on those two unless you have a way of getting more. Now what this does is it creates a BCD switch setup, binary encoded, and then it reads each channel separately. These IC chips are extremely fast. We're talking about, 10 nanoseconds, not even milliseconds, between switching times. So they can easily outrun the clock of the Arduino. So actually the Arduino is slower than these chips are capable of doing. So there's no problem there. Now I was able to get it up to 120 hertz, which is 120 cycles in 1 second, and that was on 6 channels. So that was 720. That was 720 clicks a second is what I had it at, and it was very stable and all of the reads were good. But you can literally take and use one of the clock pins now, one of the interrupt clock pins, instead of having to use 2 or 3 or 4 or 5. So let me show you how to set up this basic switch and sketch. For mine's for the robot. Anyway, with this, I got 6 channels. The Arduino's only got 2. So I had to figure something out that was cheap. Yes, these chips are cheap. You can get them for $1.25, or you can search online for a signal, a PWM to PPM converter, which is basically what this is. You can search for PWM to PPM converter if you want and pay a couple $100, or you can build it for $3. Let's get to work. Alright, so this is your basic breadboard setup. You notice on the chip up at the top, different applications. You can use them for virtually anything. That's how good what these chips are good for. Now make sure you look at the data sheet. This will show you the binary and the digital layouts what you have to use as far as your zeros and ones are concerned, and what order you have to turn them on and off. Now don't forget to put your 3 220 ohm pull down resistors in line. That's what turns off the signal. The setup is relatively easy for the input coming from the RC, as well as the wiring for the BCD switch control on the Nano there. It's all relatively straightforward. Check your own for how to hook it up. Alright, first start with your up-down counter. Is 0 to 7, pulses at 8 on the digital pulse. Now these two components are your text output and your audio beep. Text output has 2 elements. Alright, your RC servo meter is going to read once every pulse, so that's 8 times per cycle. Now this is the 1-bit spot. Every time it is activated on the 0 to 7 counter, it adds 1. It is followed by the 2-bit
So if both of them are activated, you'll get 3. If only the 2-bit is activated, you'll obviously get 2. And then after that, you have the 4-bit spot. Now, all of these are in a sequence. There is a array of zeros and ones inside each of the 1, 2, and 4-bit areas. So for each 1, 2, and 4-bit spots, you have to fill the array items in according to your graph.
Alright, we're going to go over how I put this together. Again, that's the CD 4051 chip. The top right, you see the 3 resistors. Those top 3 resistors are the pull down resistors for the input. Up on the top left, you'll see the 1 single resistor. That's the resistor for the 2 LEDs, which are located right there. One is for the power on, and the other is for the inhibit pin. When you send power to the inhibit pin, it unlatches it. So that's how we do the on-off switching, is not with the power, but with the inhibit pin. Now these are relatively basic, nothing special on the back. I tried doing a clean job, but kind of sucked. Now here, right here, are the input pins or sides. These 2 here are for channels 1 through 6 right there. This one is for channel 7 and 8. I have a 6-channel receiver, so you can use these, or I'm going to use them for something else also. This pin is the data pin, I do believe. Let me check. This is, yes, this is the return data lead. So every time it switches one, it's going to send them out through this wire one at a time. Now this set of wires here, this is the inhibit pin switch. When you send juice to this, it flips the switch off so that you can change it. Now this plug here is the actual ABC inputs for your binary on off for your 1-bit, 2-bit, and 4-bit. Alright, so we've got your radio, your RC receiver items, your Arduino control items, and power. And that's pretty much it. You can get 8 radio RC channels converted into a Arduino PWM input using just the 1 clock pin, and you don't have to use the inhibit pin, it's cleaner. And so 4 pins, 5 pins from 8, and then you can take this up to a theoretical 256 using shift registers. So on the chart here, it gives you a basic rundown of your pin numbers. Like the first channel, 0 channel, is on pin 13, which is starting 1 through 8, 9, 10, 11, 12. So it's up here, 13. Alright.
Alright, so I added the 3 lights to signify the changing of the channels digitally.
Alright, so here you can see where I added the 3 pins, LEDs. Now these LEDs, this one is for the 1 spot, the 2 spot, and the 4 spot. So when they're changing, they're all right there to go right directly to the input pins coming off.
of the main feed right there. The white, those three right there are the main switch on off. They do have their own resistor right there, which is going to the main ground right there. Okay, so that's the only change I did, was added those three. Hope you learned something. Make sure you subscribe.